Congratulations on achieving success in your electrical exams. Your hard work and dedicated preparation are evident in your positive outcome. It's rewarding to know that the available resources and advice were beneficial in your journey. Utilizing effective study materials and test-taking strategies can significantly improve exam performance. Electrical exams often require a comprehensive understanding of the National Electrical Code, electrical theory, and practical applications. Proper preparation involves thoroughly reviewing code articles, understanding fundamental electrical concepts, and practicing problem-solving techniques. It's also important to familiarize yourself with the exam format and time constraints. Test-taking strategies can help manage anxiety and optimize performance during the exam. These strategies might include carefully reading each question, eliminating incorrect answer choices, and pacing yourself to ensure that you have enough time to complete all sections. A well-structured study plan is essential for effective exam preparation. The study plan should allocate sufficient time for each topic and include regular review sessions. Practice exams are also valuable for assessing your knowledge and identifying areas that need further attention. Electrical theory encompasses a wide range of topics, including Ohm's law, Kirchhoff's laws, series and parallel circuits, and alternating current circuits. A strong understanding of these concepts is crucial for solving exam questions and applying electrical principles in real-world situations. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. The NEC covers various aspects of electrical wiring, equipment, and systems. It is essential to have a thorough understanding of the NEC to ensure compliance with safety regulations and best practices. Understanding branch circuits is important, which are the circuits that extend from the panel board to the final outlets or devices. These circuits can be classified into different types based on their amperage rating and the types of loads they serve. Common branch circuit ratings include 15 amps, 20 amps, and 30 amps. Overcurrent protection devices, such as circuit breakers and fuses, are used to protect branch circuits from overloads and short circuits. The size of the overcurrent protection device must be matched to the ampacity of the circuit conductors. Grounding and bonding are critical for electrical safety. Grounding provides a path for fault current to return to the source, while bonding ensures that all metallic parts of an electrical system are at the same potential. Proper grounding and bonding can help prevent electric shock and reduce the risk of fire. Wiring methods refer to the various types of cables and conduits used to install electrical wiring. Common wiring methods include non-metallic sheath cable, or NM cable, electrical metallic tubing, or EMT, and rigid metal conduit, or RMC. Each wiring method has its own advantages and disadvantages, and the selection of the appropriate wiring method depends on the specific application and environmental conditions. Understanding how to calculate voltage drop is important. Voltage drop is the reduction in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction and can also reduce the efficiency of the electrical system. The NEC specifies maximum allowable voltage drop for branch circuits and feeders. Electrical calculations are an essential part of electrical work. These calculations are used to determine the appropriate size of conductors, overcurrent protection devices, and other electrical components. Common electrical calculations include calculating voltage drop, determining conductor ampacity, and calculating fault current. Understanding transformers is important as transformers are used to step up or step down voltage levels. Transformers consist of two or more coils of wire wound around a common core. The ratio of the number of turns in the primary coil to the number of turns in the secondary coil determines the voltage transformation ratio. Motors are used to convert electrical energy into mechanical energy. Motors are classified into different types based on their construction and operating characteristics. Common motor types include induction motors, synchronous motors, and direct current motors. Understanding how to troubleshoot electrical circuits is important. Troubleshooting involves identifying and resolving problems in electrical circuits. Common troubleshooting techniques include visual inspection, voltage testing, and continuity testing. Safety is paramount when working with electricity. Always follow safe work practices and use appropriate personal protective equipment, or PPE. To energize circuits before working on them and use lockout/tagout procedures to prevent accidental re-energization. The NEC provides specific requirements for electrical safety, and it is essential to follow these requirements to protect yourself and others from electrical hazards. Electrical drawings and diagrams are used to represent electrical systems. These drawings and diagrams provide information about the location of electrical equipment, the wiring connections, and the control circuits. Understanding how to read and interpret electrical drawings and diagrams is essential for electrical workers. The NEC is updated every 3 years, and it is important to stay current with the latest changes. Continuing education courses and industry publications can help electrical workers stay up to date on the NEC and other important topics. In addition to technical knowledge, electrical workers also need strong communication and problem-solving skills. They must be able to communicate effectively with clients, coworkers, and other stakeholders. They must also be able to identify and solve problems efficiently and effectively. A successful career in the electrical field requires a combination of technical knowledge, practical skills, and professional attributes. By investing in your education and training, you can increase your chances of success and make a valuable contribution to the electrical industry. Understanding the different types of electrical equipment is important. This includes things like switchgear, panel boards, transformers, motors, and lighting fixtures. Each type of equipment has its own specific characteristics and applications. Switchgear is used to control and protect electrical circuits. It typically consists of circuit breakers, switches, and other protective devices. Panel boards are used to distribute electrical power to branch circuits. They typically contain circuit breakers or fuses to protect the circuits from overloads and short circuits. Transformers are used to step up or step down voltage levels. They are essential components of many electrical systems. Motors are used to convert electrical energy into mechanical energy. They are used in a wide variety of applications. Lighting fixtures are used to provide illumination. They come in a variety of styles and sizes. Understanding how to select the correct type of conductor for a particular application is important. Conductors are typically made of copper or aluminum. The size of the conductor must be appropriate for the amount of current that it will carry. The insulation on the conductor must be appropriate for the voltage and temperature of the application. Understanding how to install electrical wiring correctly is important. Electrical wiring must be installed in accordance with the NEC and other applicable codes. Wiring must be properly supported and protected from damage. Connections must be made securely and properly insulated. Understanding how to test electrical circuits is important. Testing is used to verify that circuits are working properly and that they are safe to use. Common testing procedures include voltage testing, continuity testing, and insulation resistance testing. Understanding how to troubleshoot electrical problems is important. Troubleshooting involves identifying and resolving problems in electrical circuits. Common troubleshooting techniques include visual inspection, voltage testing, and continuity testing. Understanding the different types of electrical hazards is important. Electrical hazards include electric shock, arc flash, and arc blast. Electric shock can occur when a person comes into contact with an energized conductor. Arc flash is a dangerous release of energy that can occur when there is a short circuit in an electrical system. Arc blast is a powerful explosion that can occur during an arc flash. Understanding how to protect yourself from electrical hazards is important. Use appropriate personal protective equipment, or PPE, such as gloves, safety glasses, and arc-rated clothing. To energize circuits before working on them, and use lockout/tagout procedures to prevent accidental re-energization. Follow safe work practices and be aware of your surroundings. Understanding the requirements of the NEC is essential for all electrical workers. The NEC is a comprehensive set of standards for safe electrical installations. It covers various aspects of electrical wiring, equipment, and systems. Understanding the basic principles of electricity is important. Electricity is the flow of electrons through a conductor. Voltage is the electrical potential difference between 2 points. Current is the rate of flow of electrons. Resistance is the opposition to the flow of current. Ohm's law states that voltage equals current times resistance, or volts equals amps times ohms. Understanding series and parallel circuits is important. In a series circuit, the components are connected end to end. The current is the same through all components in a series circuit. In a parallel circuit, the components are connected side by side. The voltage is the same across all components in a parallel circuit. Knowing the difference between alternating current, or AC, and direct current, or DC, is important. In AC, the current flows in one direction and then reverses direction. In DC, the current flows in only one direction. Most residential and commercial electrical systems use AC. Batteries and electronic devices typically use DC. Understanding single-phase and three-phase power is important. Single-phase power consists of one alternating current waveform. Three-phase power consists of three alternating current waveforms that are out of phase with each other. Three-phase power is typically used in industrial and commercial applications. Knowing how to read electrical meters is important. Electrical meters are used to measure voltage, current, and resistance. Analog meters use a needle to indicate the measurement. Digital meters display the measurement on a digital screen. Understanding the color codes for electrical wiring is important. The color codes are used to identify the different conductors in a circuit. In a typical 120-volt circuit, the black wire is the hot wire, the white wire is the neutral wire, and the green wire is the ground wire. Understanding how to use a multimeter is important. A multimeter is a versatile tool that can be used to measure voltage, current, resistance, and continuity. It is an essential tool for electrical workers. Knowing how to splice wires is important. Wires must be spliced correctly to ensure a safe and reliable connection. Common splicing methods include using wire connectors, soldering, and crimping. Understanding how to install electrical boxes is important. Electrical boxes are used to enclose electrical connections. They must be properly installed to protect the connections from damage and to prevent electric shock. Knowing how to install receptacles and switches is important. Receptacles are used to provide a connection point for electrical devices. Switches are used to control the flow of electricity to a device. Understanding how to install lighting fixtures is important. Lighting fixtures must be properly installed to provide adequate illumination and to prevent electrical hazards. Knowing how to install a ceiling fan is important. Ceiling fans can help to improve air circulation and to reduce energy costs. They must be properly installed to prevent them from falling. Understanding how to install a dishwasher is important. Dishwashers require both electrical and plumbing connections. They must be properly installed to prevent leaks and electrical hazards. Knowing how to install an electric range is important. Electric ranges require a high voltage electrical connection. They must be properly installed to prevent electrical hazards. Understanding how to install an electric water heater is important. Electric water heaters require a high voltage electrical connection. They must be properly installed to prevent electrical hazards. Knowing how to install a central air conditioner is important. Central air conditioners require both electrical and refrigerant connections. They must be properly installed to ensure efficient operation and to prevent leaks. Understanding how to install solar panels is important. Solar panels convert sunlight into electricity. They must be properly installed to maximize energy production and to prevent electrical hazards. Knowing how to install a generator is important. Generators provide backup power during a power outage. They must be properly installed to prevent backfeeding into the utility grid. Understanding how to inspect electrical systems is important. Inspections are used to identify potential safety hazards and to ensure that electrical systems are working properly. Understanding how to repair electrical systems is important. Repairs must be made by qualified personnel and in accordance with the NEC and other applicable codes. Knowing how to upgrade electrical systems is important. Upgrades may be necessary to accommodate increased electrical loads or to improve the safety and efficiency of the system. Understanding how to design electrical systems is important. Design involves determining the appropriate size and type of electrical equipment and wiring for a particular application. Electrical engineering principles involve advanced concepts that are important for design. These principles can involve complex circuit analysis and understanding the role of electrical engineers. They are responsible for the design, development, and testing of electrical systems and equipment. Finally, remember that success in the electrical field requires dedication, hard work, and a commitment to lifelong learning.